Hello, welcome back. This is a quick tutorial on section 9.3. Many of you have asked me a question, so I'm just recording a quick video on this one. So here is a problem. It says, this is again section 9.3, and I think this is a quiz problem. A soda company sells one of its soft drinks in 12-ounce cans. In order to ensure that every can has at least 12 ounces in it, the machine in the factory are set to fill each can with an average of 12.1 ounces of soda. So I know that my mu is equal to 12.1. Every week, a quality control technician tests 20 randomly selected cans. Okay, so N is equal to 20 because he selects 20 randomly selected cans to make sure that the average amount of soda in the cans is still 12.1 ounce. If the conclusion of the test is that the number of ounces of soda in the cans is different from 12.1. So here is the key. When they say different, remember different, H naught and HA. So what I'm going to do is I'm going to go ahead and write my H naught. Remember what H naught is? It's always equal to sign. So mu is equal to 12.1. HA is what the quality control technician thinks. What he thinks is mu is different, that is not equal to 12.1. So as soon as you see this, you know it's going to be a two-tailed test. Two-tailed test. All right, so let's go back here again. The technician will declare that the process is out of control and the machine will be stopped and calibrated. So he thinks it's not, or it's different from 12.1. So when he says it's different, it could be less or more. And he wants to stop the calibration of the machine. From previous tests, the technician assumes that the population is normally distributed and the population standard deviation is 0.018 ounces. The number of soda in the 20 cans that were tested this week is given below. So this is all the information of the 20 cans that we have. So one way of doing it is we need to find the sample mean. And I can find the sample mean by plugging all of this into my class calc, adding and then dividing by 20. But there is a quick way to do this. So let's go ahead and understand the question first. So there is a soda company that sells 12 ounces of soda cans, and they want to make sure that every can is at least 12 ounces. So they calibrate the soda machine to 12.1. Again, the quality control technician comes and checks, and then he thinks it is not equal to 12.1. Now, assume that the standard deviation from the technician's previous test is the population standard deviation, and they're asking us to calculate the test statistic. That means we have to calculate the z-score. Okay? Now, the two ways of doing it, you can always go ahead and do it manually, but I would like to use my class calc for it. So what I'm going to do is I'm going to click copy to clipboard and make sure this has been copied, okay? So it should say copied. And now I'm going to go back to my class calc and I'm going to press Control V. And as soon as I press Control V, this is all copied. And what I want you all to focus is this is copied in the variable x1. And now you go to Stats, Test, Z-Test. As you can see, this says stats, but I'm not using my stats, I'm using my data. So I'm going to click on my data. And here it's asking me the first thing is mu. And as you know, the mu value is 12.1. So let's go back here. The mu value is 12.1. The next one is standard deviation. So let's go back and check standard deviation. Standard deviation is 0.018. Standard deviation is 0.018. And the next one is L. The word L stands for, the letter L stands for the list. And as you have seen, I've copied the entire list here. Please make sure this is under X1, not Y1. So all you have to do is type X and a 1. And there you have your p-value for z not equal to. You have your z-score and you have all the information. Again, this is your z-score, and this is your p-value, and this is your z-score. If it is two-tailed test, this is your p-value. If it is a right-tailed test, this is your p-value. If it's a left-tailed test, this is your p-value. So depending on what your test is, you're going to pick that p-value, and here is your z-score. All right, hope this helps.